Okay. Um, Tom, my friend, if you guys grab, can you do me a favor? Grab the book and go to chapter 11. There's one calculation, lighting calculation problem left. Only one. One lighting calculation problem. This chapter, guys, talk about vertical calculation, Ashley. When we went, Rob, my friend, with all your beautiful camera, when we went to Halberg, you were taking pictures of all the lights. One of the lights, do you guys remember that wall wash lights, incandescent fluorescent lights? That's exactly what they're talking about. Wall wash light, calculating by hand, doing it by hand. Thanks God we have softwares, thanks God. But this is doing it by hand. We have done one problem. So take this. Here's a switch gear. Why would we do it by hand, by the way? If I have Chad Gerdes' picture right here, and I want to throw light at him because he's so important for Dustin. So you throw wall wash, right? That's a reason. Another reason is if you light the walls, the room looks nice and appealing to certain people. It's not like dark walls. So certain people like to throw lights on the walls to make it more appealing. And the third reason, which is dear to Ashley's heart, guys, is what if you have a switch gear right here and you need to be able to read the flux, the voltmeter, the power factor, read stuff from the gauges in front of the switch gear, right? You need to lift the face of the switch gear. So you can have some type of directed light, the short light at the switch gear. That's what we're doing. Okay, take this. Out of this chapter, I want you guys to know one little thing, Dustin, before you fall asleep. One little thing. Foot candle vertical. Can you see that vertical one? Foot candle vertical. This is the only one I would like you to get to remember. Equal the candela power multiplied by the sine of the angle divided by the square of the distance. This is the same formula that we used to have, guys, except it's sine, cosine if it's going horizontal. If you're shooting horizontal, cosine. If you're shooting it vertical, it becomes a sine. That's the only formula that you need to know. Rob, can I have a thumbs up, Chad? Yeah, we know it. That formula? Cool. By the way, this picture that you're looking at is actually in the book in page 94. The same picture. Okay, so this is the formula. The question for you would be then, here's a question for you. I would like to do a calculation using vertical foot candle calculation on the face of this switch gear. This is my switch gear. I need to do a vertical calculation on the face of this switch gear. This is my ceiling. If anybody's wondering, where's my ceiling, Chad? Here's my ceiling here. And here's the lighting fixture coming and shining at the front of the switch gear. So my job, Dustin, is to do the calculation. So let me show you the scenarios that we have. Scenario number one, I have the first thing. Can you guys see point number one? See where point number one is? Right in here with a 60-degree angle with the vertical right here is 60-degree angle, okay? And the distance from here to here is D, right? The distance from here to here, I'm giving it to you as 4.5. Cool? I'm giving you the distance from the lighting fixture, 2.1, as well as the angle that that 0.1 makes with the vertical. Can you guys see that? With the vertical? Okay. So, to find the foot candle at 0.1, Ashley, I would like you guys to go to Fig 11.3. Fig 11.3, the angle is 30. Can you guys get me what's the foot candle at angle 60? Anybody can see the foot candle at angle 60? 584. Everybody can read that? 500. Oops. This is the sign at angle 60. Okay. So the foot candle at angle 60 is 335. Because I don't have 60, I go to the next, the closest to it. Can you guys see that? From that little table right here, I have 55 and 65. So I have 60. I'm going to go to the next one, which is 335. Cool? So I grab the 335. This is the foot candle at angle 60. Then take the sine of the 60 divided by the distance, which is 4.5 feet. That will get you 14.3 foot candle at the face of the switch gear. Any questions about that? At the face of the switch gear, you put this, the angle is 60. The foot candle from the table, Fig 11.3 is 335. Do the math, get you 14.5. Where did we get the 335? Can you guys see where we can get right here from 60, fig 11.3s? You have to go to 65, right? Why 65? Because I don't have 60 and I'm lazy to do interpolation. So 65 give you 3335, plug it into the formula, get you 14.3. Any question about 14.3? Straightforward, no gimmicks, nothing. Jackson, my friend, any question about that? Okay, let me do the calculation for point 2. I have another point, point 2. Point 2 happens to be at angle 50 and at distance 4.6, which is that distance right here. At distance, the distance is 5.1. The distance is 5.1. My distance 5.1. Okay, so if you guys go to 50 degrees from the table, 50, I don't have 50, so I need to go to 55, 696, multiply it by sine 50, divide by 5.1, get you 20.5. So at point 2, I have 20.5, I have a 20.5 foot candle, 20.5 foot candle. By the way, these green ones, Ashley, the green numbers here are the elevation. These are the elevation of these points. It will help you calculate the distance, the elevation of these points. You're going to see later, they're going to be helping me calculate the distance, elevation. Any question, guys, about calculating the foot candle at point 1 and point 2? You really need to know two things. You need to know the distance. So you might have to use Pythagorean theory to find the hypotenuse of this. Can you guys see that there is a triangle here that you need to find the hypotenuse if it's not given? And number 2, you have to know the angle. The angle is given, and then from the angle and the distance, you can find the foot candle at the face of this switchgear. One more point, point 3. Look at point 3 here. I have foot candle at point 3. Let's go directly to point 3. Here's point 3. The candela power is 842 multiplied by sine 40, divide by 60, because that's point 3. If you guys go back, point 3 is actually 6. The distance is 6. The angle is 40. Right? So for angle 40, I have to go to 45 because I don't have 40. So for 45, I have 842 multiplied by sine 40 divided by the square of 6, giving me 15 foot candle. Any question, guys, about finding these foot candles, 3 foot candles on the face of a switchgear? Any question about this? 3 foot candles on the face of a switchgear. The rest, Ashley, my friend, is finding the maximum. I have 3 points. I want you to pick the maximum, the minimum, and the average. So what do you do? Which one is the maximum? 20.5, Chad. There's 3 of them. Which one is the minimum? 14.3. Which one? What's the average? What do you do when you have 3 points and you need to average them? Add them up, divided by their number. Add, divide by number. So the average on the face of this switchgear is actually 16.5. One more time. Here's the switchgear. Calculated, I did 3 points. Now, how, my friend, I can do as many points as I want. I can do as many points as I want. So on a test, here's what I'm going to do to you guys on the test. I will put 3 points on the face, vertical, and say, do the calculation for it. Find the minimum, the maximum, and the average. Right? And the minimum, the minimum number, maximum number, and average number of the foot candle. Any question, guys, about finding the foot candle on the face of a switchgear? Can I have thumbs up, Chad? It's yes, no. This is a PDF too. It will be PDF for you. Just to orient yourself, the points are right in here. Can you guys see point 1, point 2, point 3? The D is given 4.5, 5.1, 60. The angles are given 60, 50, 40. And the green numbers here are the elevation. The elevation. That's it. That's what chapter 11 is. Finding a vertical foot candle. A lot of people, when you do vertical foot candle, you need to use this formula. CP, candela power, multiplied by sine of the angle with the vertical, divided by the square of a distance. The square of a distance. Any question, guys, about this? Dustin, my friend. Okay, so that's now. Actually, you would never be able to solve this problem unless I give you a graphic like this, guys, with angles and foot and candela power. So you can't. I have to. So this one is for a fixture that's actually F34 T8 fluorescent. Okay. Any question about the maximum, minimum? Just find the maximum number, minimum number, and average them. Okay. Take this. Here's another example. Another example. In this example, guys, we need to find we need to find the calculation at point 1. Okay. So we need to find the calculation point 1. Let me show you what's going on here. We have a fixture. Can you guys see my fixture here? It's let's do. This is the ceiling here. I have my fixture. Here is point 1, guys. I have my fixture and I have my point 1, and I need to find the distance. The fixture is placed 20 feet away from the board, 20 feet away from the board, and at a distance of 10 feet, 6 feet. The height of the whole switch gear is 8 feet. So that will make this triangle. Can you guys see that this triangle now is 2 by 10? This triangle is 2 by 10 triangle. Look at this. I need to find the calculation right at this point. This point is 6 feet away from the floor. The height of the switch gear is 8. So if this is 6 and this is 8, that will give you this one what? 2, right? The distance from the switch gear is 10 feet. So I need to find D. How do you find D for a triangle that has 2 sides? Right angle triangle. One is 2 and one is 10. Use Pythagorean theory, square the 2 sides and take the square root of them, add them up, take the square root of them. That will give you a distance of 10.2. 10.2. Any question, guys, about finding the distance? Any question about finding the distance? Okay. Any question about finding the distance? The second one here, I think I want to adjust it slightly here. Let's do this. Foot cannon vertical. Okay. So let's do find Q. Okay. All right. So we want. I'm going to take this one too out. Actually, Q should be with the vertical. So I'm going to take this angle here. This is my Q. The Q that with the angle make with the vertical. Okay. One more time, guys. Can you see what we're doing here? We're trying to find the distance. Any question about how to find the distance, Ashley? How to find the distance? I have a 10 feet and a 2 feet. Take the hypotenuse is square the 10, square the 2, take the square of it. That will give you a 10.2. So the D is 10.2. Any question about 10.2? The second thing that we need to find is the angle. Can you guys see the angle? The angle is Q. I need to find the angle. So Q equal inverse tan, right? Opposite over the adjacent is the tan. 10 over 2 equal 5. So what's the inverse? Where's my calculator? Oops. Can you guys get me the inverse of 5? The inverse tan of 5. Inverse tan of 5? 78. Huh? 78.7. So 79. 79 degree. So the inverse tan of 5 is 78, right? 79. 79. Thank you. 79. So this is my tan inverse. I should probably put it properly in math. Tan inverse 5 equal tan inverse 5 equals 79. One more time. To find the Q, guys, I need to take the opposite over the adjacent, right? Opposite over adjacent is 10. The opposite is 10 divided by the adjacent 2. That will give me 5. Tan inverse 5. tan inverse 5 is what? 75. Anybody can disagree with my friend? Tan inverse 10 over 2 equal tan inverse 5 equals 79. Any question about finding the angle? Any question about finding the angle? Question about finding the angle. Found the angle. Okay, so we found the angle. Okay, so we found this angle. The second thing I need to do is I need to find the foot candle. Foot candle vertical equal candela power times sine Q divided by distance squared equal. All right, let's start candela power at 79. What's candela power at 79, guys? Right from here. What's the candela power at 79? The closest to it. Well, I have 75 or 85. Which one will I go? My option is to go 75 or 85. I'll go to closest 75. So at 75, it's 206. So this is 206 times sine 75 divided by distance. What's the distance? 10 to the power 2. Can anybody give me the answer for this? One more time. We found the D. Can you guys see the D here? We found the D. Any question about what's the answer? When you guys have give me an answer for that. 2? 2? Okay, so 2. Why are you coming here? 2. Are you Skyping me here or what? 2. Any question guys about this? Very easy. Tau, the only thing you need to do is find the angle, find the D, and plug them into this formula. Really piece of cake. Not really nothing to it. If I ask you guys to find the distance at this point, like if I ask you at this point, this is point 1. If I ask you at point 2, and here is point 3, right? The only difference is going to be what? The angle and the distance. So you're going to find the distance for this. This will be a triangle of 10. If you take 2 and 6, so D will be 6 squared plus 10 squared, square root of both added. At point 2, this is 4, so that will give me another 4. Yeah, 4 squared, square root of that. So, any question, guys, about finding the angle and the distance? Phil, does it make sense? If I ask you guys to find the angle and the distance at point 2 and at point 3, would it be hard to find the distance and the angle at point 2 and plug them in? The first one that I did is point 1. Right at point 1. At point 1. Any question, guys, about finding the foot candle calculation? Foot candle calculation. Before we move into a different topic. Any question? Foot candle calculation. Just for the heck of it, I want to do, let's just say this, the fig is 11.3. This is my, I want to erase this one here and write in this little corner, I'm going to find D for point 2. Let's say point 2, at point 2. Can you guys, everybody can see that at point 2, what's the D? Right at point 2 here. It's 10 squared plus what? What is this? This is 4. 6. Thank you. 10 squared plus, no, at 4 minus 8. 8 minus 4 is what? 4 squared. Okay, Aladu, can you do that for me, please? What's the D? 100 plus 116, square root of 116. Phil? What? 10.8, 10.8. Okay, here is 10.8. T. Okay, let's find the angle. Let's call this angle right here, right? A Q1. So Q, oops. Oh, come on. Q1 Okay, Q1 equal tan inverse. Okay, opposite is tan inverse. What is it? Help me here. Tan inverse 10 over 4. Okay, what's tan inverse 2.5? 10 over 4, right? It's 2.5. What's tan inverse 2.5? Rob? 68. I need the second. 68. 68 degrees. Now you have the distance, and you have the distance, and you have the angle. I'm not going to do it, but you guys go plug in the distance and the angle in this formula, and find the foot candle at point 2. Any question, guys, about this? Any question? So that's it. That's what all chapter. This is the last thing we're going to do calculation for lighting, guys, this quarter. So congratulations, you have done all the hands-on calculation for lighting. Okay. Any question before I move? This is Alaribo is PDF and on the network. It will be PDF and on the network. All right. Chapter 12. I'm going to look at chapter 12 and 16 together, guys, because they're related. So could you please go quick with chapter 12? There's no calculation chapter 12 and 16. Chapter 12 talk about computer-aided lighting. And chapter 16 talk about making lighting drawings step by step. Cool? Can you guys look at these two? I'm going to lump sum them in one and summarize them in a couple of a slide or two. Okay, a couple of things. This is you, Tao. I'm going to keep picking on Tao and Ashley and Jackson and Rob. You guys have done that with me, with visual. This is just really summarize what we've done in visual, right? If you have computer aided, which I hope you would, because you don't want to do lighting calculation by hand ever, unless you want to be certified lighting designer as part of your exam. Computer aided and lighting design. These are the two chapters talk about how do you use a computer to get all these calculations for you. You guys have done visual for me. You have, each one of you is going to be doing 6 reports from visual, printing it into your project. So this is review of what we're going to be doing. Okay, so first thing, software that you can use. We have visual Lithonia, right? You guys are familiar with that. The major one is AGI. AGI can get you rendering, take you to the next level. My understanding, Tao, and I'm not an expert in lighting, is you can get away with visual for almost, I would say, 80% of what you need for light. There's 20% is very specialized lighting system. You might have to use a specialized commercially available lighting software called the AGI. Cool? All right, so that's basically the software that we can use. Lighting drawing setup. Do you guys remember when we did the setup for visual? What did we do? Inside or outside? The first decision you have to make. This is a review of what we did in visual. Do you guys remember how we did? There are 2 ways. You have to set up visual into, are you doing inside calculation, so reflection is a big deal, or are you doing outside where reflection is not a big deal? There are no walls around the parking lot. Cool? So that's decision 1. Decision 2, import drawing from CAD. DWG file, import it to visual, right? Isn't that what we did? Because remember what we imported the DWG file into visual or AGI? Okay. Then, second step, build 3D model. And Ashley went and she put all these rooms all over in the model that we did. We built the model. Then find IES file for the Lumineers. Remember how we went into the library for every single fixture and we found the IES file for them, guys? And that was kind of the challenge. Which one am I going to use, Chad? Right? And then place the Lumineer in the model, right? When we find it, we stick it right into the model. That's exactly, you guys did that one for me. You placed it in the model, and number 6, establish calculation zone. Calculation zone, typically 2.5 for offices, hallways 0. And the last step for using the software, guys, is what? Run the software, right? Isn't that what we did? Again, this is PDF and will be for you. I know I'm going fast on that one for you to calculate, but it's PDF. So what I did, Phil, summarized how we did with software. And I know I went through the steps with you when we were doing visual. This is what we did for visual. If you do AGI, very similar. These are the steps that you use to use lighting software calculation, for the most part. Can I have thumbs up being Chad? We've done it. We know what it is. Yes, Tao? Did you get your breakfast, Tao, today? It's Friday, huh? Any question, guys, about these 7 steps? You call them 8, whatever you call them. Really, step by step, not a big deal. One, the first thing, decide, are you doing inside or outside? You have to make this decision. Then, because you have to click on inside or outside. Then, import the DWG file, that's the drawing. Build the 3D, bring the IES file from the library that comes with the software. Place the fixtures right where you want them, right? And then establish, you need to establish calculation zone, which is 2.5 or 0 for hallways, 2.5 everywhere, and run the software, push the button. Is that hard? Piece of cake. Okay, now what happened when you do all this? What's the outcome, right? What is the outcome from the software? Again, guys, I can't emphasize, we have done visual. This is just quick review, otherwise I'll spend more time even there. The outcome, here's the outcomes. You can find the maximum, minimum, average foot candle. Maximum, minimum, average foot candle. Very, very important. Second, maximum to minimum ratio. Maximum to average, minimum to average. The layout of the fixtures. Rendering. You can do rendering with the software. We didn't do that. You can render. Lumineers schedule. We did that. Project documentation. We did that. These are the outcomes after you run the software. What are you supposed to do? Alaribo, can you agree that we are doing it for our project? You guys are putting it in our binder. That's exactly what you're doing in our binder. One more time. When we build the system, what are the outcomes? What are the outcomes? The outcome, again, you need to find the maximum foot candle, the brightest spot in your room, the darkest spot in your room, the minimum, the average, right? Foot candles. Then maximum to minimum. Maximum to minimum actually makes your eyes, if the maximum to minimum is 1, it means it's uniform distribution of light in the area, right? What we are shooting, guys, over is all these maximum to minimum, maximum to average, all these to be as close to 1 as possible, right? The closer the number to 1, the better the design would be. Now, if my maximum to minimum is 100, this means in that little corner there, it could be 0-foot candle, and right where I'm standing, 100-foot candle. Imagine your eyes going from a 0, opening your eyes into 100, closing your eyes. Imagine the stress that will your eye will be under as you move and work under these environment. So that's a big deal. Okay, so where do we get the average, guys? IES standards of North America have an average for different areas and minimum for different areas too that you can maintain. Any question about the outcome? Layout of the luminaire, who cares? Now when Ashley or anybody else wants to go to place a fixture, we need to tell them where to put the fixture to get the right foot candle in this hospital, right? So you have to find the layout of the fixtures. That's a big deal. For us, guys, we imported it into CAD back into Revit, right? Can I have thumbs up, guys? We understand how we did visual, and AGI will be very similar, right? Tom, my friend, I'm going to keep picking on you until you say no. Okay, so that's basically it, guys. These 2 chapters talk about how to use the software and what are the outcomes of these software, computer aided, and what are the outcomes of the software. Not a whole lot to it. And again, I summarized it for you guys in a couple of steps. Any comments, guys, about this? Any comments, any questions? Any comments, any questions? That's it. So if you go to 12 and 16, computer aided lighting design and lighting drawing setup, we showed you here's the setup and here's the software that can do, that you can use. By the way, Cooper Busman and Cooper has its own software. GE also, Rob, if you're doing GE lighting, they will give you a software free. I'm familiar with visual. And if you want the software that works with anyone, AGI. Now, Jackson, my friend, visual that we used was Lithuania. But what if you have a GE fixture? Can I run a GE fixture in Lithuania? No problem, as long as they have the IES file. IES file, guys, is international. Like, for example, Dustin, if you have a DWG file, can you open it from any software that deals with DWG file? Yeah, no problem. Doesn't have to be CAD. These are standard. Does that make sense, guys? For example, if you take a receptacle, 15 amp plug 120 from Minneapolis here into Houston or into New York, right? And you plug it in. Should it fit? Yes, it's standard. Same thing with these guys are almost international. These are international standard. IES file and DWG files. Can I have thumbs up, Chad? We got it? Okay. So that's these two. Now let me move you guys into chapter 13. Chapter 13 is really interesting. It talks about the industrial luminaires and any luminaires. A couple of things I would like to mention for this one, my favorite. A couple of things, guys, when you do industrial luminaires or commercial luminaires, cost. The first, when you guys are doing estimating with Chad, right? With McCormick. The first thing we did about luminaires yesterday, what did we say? The luminaires have to be coated. Why? Because a fixture is $80 above your head, or I can buy a direct, indirect T5 fixture that can run probably $200-$300, depending on how you size it. So fixtures, guys, could be very cheap or very expensive, okay? A couple of things about industrial luminaires is the cost. The cost, so that was chapter 13. Let's go directly into chapter. Okay, so special consideration and characteristics. So the first thing we're going to do, consideration is the cost. Initial cost. Initial cost is day one. Is it an expensive fixture? What happens if you buy an expensive fixture? More efficient. More efficient fixture or what? Expensive fixture. So that's what the thing that you have to do. Initial cost. Do I want to buy a $180 fixture or a $150 fixture? That's a decision that you're going to make. Second, maintenance cost. The ballast, the lamps, and the fixtures. Cleaning the fixtures. Maintaining. How easy it is to clean a fixture like this versus a fixture that has all these louvers and so forth. So when you buy a fixture, you have to pay attention to the maintenance cost. Maintaining the ballast, changing them. Is it easy, or do I have to have 2 electricians every time I have to pick up that fixture? Lamps, relamping, and the fixture changing and cleaning. Can I have a thumbs up, guys, for the maintenance? Cost 1 is initial cost. That's the money you pay day 1. Maintenance. Second one, which is the most important right now, guys, is operation cost. For fixtures, you have to pay attention to the operation cost of the fixture. We're becoming environmentally friendly. That's why Tau, you guys ran energy code with Chad. US ComCheck energy code. Why do you think we ran it? The operating cost of the fixture is the substantial amount of percentage of the overall cost, total cost of the whole fixture. So you need energy code, and you need your fixture to be efficient. Why? You don't want it to cost too much money. Okay. So between, can you guys see that? And this is, for the most part, right? Between these two, the maintenance cost, Dustin, and the operating cost, they will make 75% of the total cost of the whole system. The whole lighting system from the get-go, when you buy it and you install it, right? You buy it, the initial cost, the maintenance as well as the operation is 75%. 3/4 of your cost is going to be how to maintain and operate these fixtures. And Phil, that's why ComCheck comes in and jump and start saying, oh, by the way, you have to run an energy code in these fixtures. Can I have thumbs up, Chad? We understand that the operating and the maintenance of the fixtures is a big deal, right? Okay. The smarter than Chad came up with a number, a magic number called NPV. What's your NPV? You're going to ask, what is the NPV of this fixture? The NPV, guys, is called net percent value. Net percent value. The net percent value, Tau, takes into consideration all of the above. All of the above. And give a value for the fixture. If the net percent value, taking into consideration the initial cost, the operating and the maintenance, is high or low, then that fixture is good or bad. Does that make sense? Then in that you make your decision based on the so-called NPV of the fixture. So for example, a fixture that's very cheap, but it's high to maintain and high to operate. The net percent value will be very high for that one, so it's not a good fixture. Any comments, guys, about these consideration when you run the electrical system? Any question? Okay, so that's basically so these are basically the major things that you take when you talk about cost of a fixture. Any question, guys, about the cost? Always, they suggest how they always spend a lot. The whole suggestion is spend good amount of money on the initial cost, and overall the life of the fixture, it will cost you less to maintain it and definitely to operate it. Definitely to operate it. Any comments, any questions? If I to dare to throw numbers on these guys, percentage numbers on these, if I'm to dare, I'm going to dare here and say here's a 25% for initial cost over the life of the fixture, and here's another 25% for actually to maintain this fixture, and here's a 50% for the energy that we're going to pay for Excel energy. So if the fixture over the life of that fixture is going to cost me $1. Makes sense? $1. Okay? Over, say, 3 years of the life of that fixture, or 5 years. So it cost me $1. Out of this $1, 25 cents would be going to buy it, and 25 cents will be to maintain it, clean it, change the ballast, relamp, and all this good stuff. And the last 50% is to pay cost for kW, kilowatt hour, that's going to be burning. Do you understand why we're after the reducing the energy code is always after the what? The energy. That's why compact fluorescent and LEDs is becoming a big deal. Lighting load, guys, is a big chunk of your load is lighting load, and we can always minimize that lighting load. If you pay $100,000 on energy bill, guys, and I can reduce it by 20%, that's a lot of money saved, and a lot of plants saved, and we save Mother Nature. If you guys are not tree huggers or anything else. Any comments, guys, about the cost? Any comments about the cost? Can I have thumbs up that, Chad, we got the cost? The VPN value. Now, maintenance and so forth. Okay. The other consideration, especially in an industrial, we're going to be doing it next project, Tom, my friend. The other consideration when you put a luminaire in the industrial location, is it a damp location? So I need a fixture for damp location, a wet location, wet rated fixture, or a dry location. That's good. You can't put a dry location fixture in a wet location, right? So can I put this fixture right here outside? No, this is a dry location fixture. You can't put it. Okay, so that's consideration number one. Consideration number two, hazardous location. Hazardous location, guys. Gas stations, grain elevators, all these location, aircraft hangars, garages, commercial garages, hospitals, where they put you to sleep. All these areas have some type of a hazardous gas, liquid, or vapor, or flare, right? So if you need a fixture into class 1 div 1, this is the flammable gases and vapors, or combustible dust class 2, or ignitable fibers class 3. We'll talk about this, guys, next quarter. These three major classification. Division 1, the hazard exists all the time. Division 2, under abnormal condition, the hazard exists. This is where in Division 3 is where we store this material. There's an explosion. These are places where the lighting fixture could create an explosion. They also go by gas. What type of gas? For these two at least, they have groups. They call them groups. Not enough to be a flammable gas, but what group? Based on the group, the flash point of this gas would be higher or lower. The lower the flash point of the gas, the more dangerous the gas is. or the liquid or the vapor is. Okay, so long story short, without getting into all these details, you are in a class 1 div 1 location, right? Class 1 div 1 or div 2 location. You have to buy a fixture like we're going to do next project that's rated for, right on it says class 1 div 1 group A, B, C, D. A, B, C, D, E, F. E, F goes with a class 2, and A, B, C, D goes with a class 1 location. So for the time being, a lot of people, when you put a fixture, be very aware of, is the place hazardous, is it classified location? For example, I think this place is classified location because Chad's voice is hazard. Oops, they say that. So do we have a flammable gas here or liquid? No. Combustible dust? No. We have dust, but not combustible dust. Do we have flammable combustible dust fibers? No. So it's non-classified location. All I have to pay attention to, dry location fixture, done. Outdoor, wet location fixture, done. In a gas station, in a class 1 div 1 location, I have to have a fixture that's capable of containing the explosion inside this fixture. So anyway, so please pay a lot of attention to the classified location. C1, class 1, D1, div 1, D2, div 2, and so forth. Any question, guys, about that? The classified location. Classified location for these. The second thing, floodlight, guys. When you put a floodlight for the, this is for the highways, we don't involve a lot with that. You have to pay attention to the FAA and FCC regulations. Now you put a 50-60 foot tower there on the intersection of 494 and say 169, and you want to put one of these big floodlight there. You have to pay attention to the FCC, right? The regulation, FAA, airplanes, and FCC, the communication regulations. All these becomes, now this becomes an issue only if you're doing highways and big floodlights. Most of you guys probably wouldn't do that. And the last thing, my friend, is emergency light. The emergency light, you need 1 foot candle, maintained 1 foot candle, like we said, by safety code, or what do you call it, building code. You need to maintain foot candle. So if this is my egress path, I have to put a bug eyes there that maintain 1 foot candle for just one, not 50, one, to be able for all of us to see our way out of the building upon the existence of an emergency. So I threw a couple of examples. You guys, we have done it. Here's a bug eye here. Can you guys see if this is the egress? These are all public places, and I need the people to be able to come in here and exit, or come in here. Can you see how the flow of traffic going this way, the flow of traffic going this way, the flow of the traffic going this way, and the flow of the traffic going this way? And here's, can you guys see where we situate them? We situate them in a places where can give the people ample amount of light, which is code 1 foot candle, so they can exit the building safely. Exit the building safely. We didn't do emergency calculation with visual. You can. You can take say 6 foot path here and make a calculation zone and maintain an average of 1 foot candle using a bug eye. We haven't done that. Any question, guys, about these considerations when you put in a commercial or industrial building, especially industrial buildings for hazardous location? Any question about these? So let me recoup. Location, damp or wet, location, hazardous location, all these flammable gases, combustible dust, ignitable fibers, big deal. Floodlights, you have to adhere to FAA and FCC regulations, airplanes and communication, and emergency light, 1 foot candle. And that's basically about it in terms of consideration for lighting fixtures. So this chapter covers 2 things. Tal, please read it one time in your life, guys, a couple of pages. One is the cost, and I'm going to summarize with the cost with the NPV value. You get an NPV value for this fixture that take into consideration the initial, the maintenance and operation cost. The rule of thumb when you become an expert in lighting design is you need to buy a fixture that's expensive initially, but cheaper to operate it. Why? Because look at the percentage of the dollars going towards the initial cost versus the percentage of the dollars going towards the maintenance cost. Over the life of the fixture, it will be cheaper to buy an expensive fixture and maintain it than to buy a cheaper fixture and maintain it, and you have to spend a lot of money to maintain it and a lot of money to operate it. Okay? That's it. That's why LEDs are becoming compact fluorescent, T5, all these. It's an explosion. Of why? Because of that 50% almost cost. Okay. And then you move on into the locations. Any comments, any questions? Any comments, guys? Any questions about this? Okay, I'm going to give you guys 5 minutes, and I'm going to do one little thing, and then let you work on the estimation. Cool? 5 minutes, please. Thank you, my friends. Okay, if you can do me a favor, can you guys go to chapter 15, the last chapter in this book, and then we're done. Display light. If you get involved in the light for not general purpose light for display. For example, display produce, display merchandise, display cars, and all these are the lights that's supposed to shine on things so we can buy it. Am I clear about what we are talking about here? Special type of lights that for things to display, to look at, or to buy, produce merchandise, artwork, and all this good stuff. Come on, am I clear about this? Special type of light. Okay. When you deal with this display light, they call them, the most important thing is called criteria. The display light criteria. In order for me to make a Laribo stand out, I have to throw 300 to 500 more lights on a Laribo than the surrounding to make him stand out. Cool? So that's basically the rule, almost the rules of the display. Make things stand out by throwing more lights at the merchandise than what the surrounding is. Okay? So if I have an object here, guys, I want this object to stand out right here in the middle. So this, in order for the object to stand out, and let's just say, make it simple, I need 1 foot candle. I want to make the surrounding here 1 foot candle, what do you guys think that object I have to throw at him? 5 foot candle. So the object, you throw 5 foot candle and 1 foot candle the surrounding. Am I clear about, guys, making things stand out by throwing light at it? Like theater, right? See that light, people who are singing and following him and all this stuff, make him stand out. Cool? So remember, throw more lights at the object so they can stand out. Rule of thumb, 300 to 500% more. So surrounding 1, the object 5. Any question, guys, about the criteria of display? Okay? Next, you can use for display, guys, a couple of things. They call it the high voltage, and I hate to use the word high voltage here. The high voltage here, they're using for the most part 120 volts. That's what they mean by high voltage. You can use high voltage. You can use an incandescent lamp, or you can use a fluorescent lamp or HID lamp. Any of these could be used for display, right? Even LEDs used for display right now. Low voltage. I have low voltage. Low voltage like 24 volt, 12 volt. Right? You see them, guys, a lot in certain, like car incandescent light, 24 volt, 12 volts, that you can use also for display. A lot of stuff they use low voltage to shine on things, objects, artifacts, and so forth, arts. So these are the type of light you can use. You can use 120 or you can use 24 volt, mostly incandescent. The key point for display light, guys, is one word: reflectors. You need to be able to shine, make the light, and make the light, beam that light directly at the object. So in order to beam the light at the object, what do you need? You need really good reflectors. So not only reflect the light, but also channel the light, reflect and channel the light towards the object. Am I clear, guys, about the reflectors? You need a good reflector that can not only reflect the light, but also channel it toward the object. Cool? So that's a key point, reflector. You can also use metal halide. There's metal halide lamps, guys, used to make the produce look more appealing, like cucumbers, more fresh. They put certain light to make certain things look more fresh, like cucumbers and lettuce and so forth in merchandise. Or of course things to look more beautiful than they are by throwing different colors and so forth on them. So metal halide used probably for making things appeal, merchandise more fresh. Okay, how does the whole system work? Here's an example, guys. I want you to look at, please, if you guys do me a favor, just look at page 118. In 118, what I drew here, a sample is 118. I want you guys to look page 118, please. And if you look at, there are two tables. Look at 15.1, the first table from the left, and the first light, the light that says Q45 PAR 38 FL fluorescent. Can you guys see that? First of all, you see the lamp performance data. This is tungsten halogen reflected lamps, a special type of lamps you can use for display. What I'm looking at, Phil, is the first lamp, right? Q45 PAR 38 fluorescent. Okay, the first thing you can get about it, can you guys see the rated life for these fixtures? It's an incandescent lamp, so so this is tungsten, so it's a 2000 hours. The second one is beam spread. Can you guys see the beam spread that says 28 by 28? Here's what that means. Here's your friend Chad when he was 11 years old, as skinny as this, right? And I need to shine the object at it using this lamp. Here's a fixture. So then I have my beam 28 by 28 degrees, I guess. So you put the fixture right here. Can you guys see where the fixture is? And it's shooting the light with a beam of 28 by 28. And here's the center of the beam to make sure the light is going directly where it should be, right? That's what 28, 28. Then do you see where it says distance, guys? Where it says distance? Here's the distance from the distance between the light and the object that you're trying to shine the light at. Can you see what distance you can get? 4, 6, or 8, depending on how you place it. So let's just say, let's use the first one. My distance was 4 here, 4 feet, right? I will put these light 4 feet away from the object, okay? If I do that, then the initial candelas at the beam center, then the candela right here at the beam center, can you guys see it's 113 candelas? Everybody can see that? Right at the beam of the center, okay? Then the beam length is 3, and the beam length and the beam width is 3, so 3 by 3 beam width, and maximum spacing between the fixtures, maximum spacing here to get uniform is 3 feet. So when I put, in order to maintain this, I need to put another fixture 3 feet away. If I am to keep, say if I have a row of vegetables and I will lit these row, I have to put them 3 feet, every 3 feet, and I have to put them 4 feet away from the object at a fixture that can give me 28 beam. So that's basically what that is. You go by the beam because you need to beam that light directly at the object. And based on the beam, it gives you the distance, how far the fixture has to be from the object, and the spacing for these objects, the spacing. If it's a continuous, if there's another picture here and a third picture here, it will give you the spacing for these display fixtures. Any questions about this? I don't like to spend too much time on it. It's specialized. If you become a lighting expert like my friend Nick one day, that becomes a niche where you have to get into display light and theater light, and it's a whole different animal. We, for the most part, 99% of us probably will be involved in general lighting, maybe special lights for special areas. That's about it. Merchandise light, you could be, if you're doing, when you guys do Target stores at Michelle Cool Erickson, a lot of lights goes into merchandise lights, but they add, it's an adder. They put your general lights first, and then they keep adding more specific lights, like task lights for merchandise and so forth. Any questions guys about how the whole system works? They go by beam, distance, and spacing for this fixture. Each fixture will give you different beam, different spacing, and different foot candle in the center of the beam. The last thing I want to talk about in this topic is fading. Lights, guys, can produce, most light produce UV and IR, ultraviolet, infrared rays. These guys can cook equipment, cook them as in damaging. So if I have a beautiful picture here, and they will shine the light at that picture. You have to be very careful that light might damage that very expensive artifacts that you're trying to display. So the smarter than Chad use filters actually to filter all these rays so they don't damage the Constitution of the United States, right? The original copy is sitting there with light so you can see it. So you have to put them in a special location, special temperature, special light so they don't damage these very important historical documentations or beautiful pictures. So that's the only thing I want to say about fading. These lights can create fade that needs to be treated. You need to pay a lot of attention to, especially if you are trying to display cucumbers and lettuce. Not a whole lot of fading going on there, right? You want to make them fresh, look fresh. If you're trying to display the Constitution of the United States, and you throw light at it, or a very beautiful, very expensive arts, then you have to pay a lot of attention to this issue. Any comments, guys, about this chapter? Any comments, any questions? That's about it. So what are you going to do, me, Tom, my friend? You're going to read it tonight. Oops. And that's about it. That's all we have for you. Any comments, any questions, guys? Jackson, my friend? Cool. Okay, so that will wrap up basically our lighting class this year. You're going to hear Chad talk about lighting next quarter only on the terms of software. We use software to design an industrial building lighting. That's about it. So hopefully, guys, this will give you enough information to understand the science of lighting. Some of you might become lighting designers at one time, and then you get into the IES classes and get certified as a lighting designer. I strongly encourage you, Rob, my friend, especially if you work for engineering firms, to track that lighting designer business. You'll get lighting certified and job security #1 and also status #2. Maybe comes a little bit of money. Okay, that's it. Thank you.